Good morning, everyone. Thank you for coming this early on the third day. Good to see so many showing up. When I say Windows, you all probably have your own picture in your mind of what that means to you. To me, it's a significant part of my journey in personal computers. I started out before there were enough pixels on the screen to actually even contemplate Windows. But, you know, technology changes fast, it grows in capacity, and apps started inventing their own windowing systems. Each app had their own. Each app had a new you had to learn. But you could be more productive in those apps. Again, technology rushes ahead, and eventually the system started doing windowing for you. Now you could be productive between apps. And this is kind of where the windowing model and windowing APIs were grounded and invented. And that's what stuck around. Sure, the computers got more powerful, we got more displays, it got nicer UX, some new frameworks to use for you, but pretty much the same windowing model. But in 2007, something happened. We started focusing ourselves on a single screen again, small, handheld, but high-res. This led to people starting using a single app at a time again. And it was in this context that our universal application platform was designed and architected. And that is what we today call the UWP. So with Windows 8, we pretty much brought you that experience, but on all our devices. We got some feedback, we heard you, and we adapted. So in 2015, I had the privilege of standing here on stage and be able to say that we put the S back in Windows. And now we could do windowed Windows in Windows again. But it was still very limited. You could pretty much only pop up content inside your own core window. If you tried to position it at a place where it would normally pop outside of your window, we would clip it. And the only way to get out of that bound was to spin up a full new window. And in doing so, well, Windows took care of where that got positioned for you. You had no say in this. And if the user moved it around, dismissed it, and wanted to recreate it, it popped back in that same position. So we heard your feedback there. We started working on new APIs to enable you to do more powerful things. Meanwhile, screens got larger, got a higher resolution. Your TV became smart. Your home entertainment system became something more than just watching video or playing games. And in the conference rooms, your whiteboards turned interactive. So we tried to incorporate that as we were reworking our model. At the same time, though, in a secret lab here in Redmond, something was brewing. And when that got announced, my first reaction was, oh my God, this is so cool! Finally, a step closer to the holodeck. My second thought, being in charge of windowing, was, wow, how do we make this manageable? We now have devices that go all the way from something you wear on your wrist, via your normal PCs and tablets, up to something you wear on your face. So how can we empower you to create apps for today's Windows ecosystem? But I'm pretty sure out there's another lab somewhere thinking of something else that is going to disrupt how we think about windowing. So the question is not how we make you create apps for today's ecosystem, but also for whatever the future might bring. My name is Robert Carman. I'm PMing windowing and windowing APIs. And if you stick around for the next 40 minutes or so, we are going to give you an overview of our new windowing model, its basic objects that you can use, the APIs that enables you to do more creative stuff with Windows in Windows. So let's address the first big feedback we always hear when we talk about multiple windows in UWP. It's hard. And oh boy, do I get it. This is the boilerplate code for just getting another window on top of the screen, separate from the one you already had. And this is not all. There is a lot of helper functionality behind this. There's hundreds of lines of code just to make sure that it doesn't fall over. And you have to have a full SAML page and frame in that window. Basically, you can't do anything lightweight. So we decided, let's address that first. So here is the new code for getting a single window on top of the screen. It's basically a new windowing class called application window, which you create, you attach content to it, and you show it on screen. Simple as that. And when I say content, that's really a UI element in this case. You can take anything and put it in a window, even a button if you wanted to spawn that out as a separate window. The core of this is the application window and the application window type. And we'll dive into this as we go along and describe this in the different scenarios. The application window is a stage rollout. We're starting by giving you a window which is a companion to your current window. It will continue to grow, and eventually it will have all the capabilities that your application view/core window has today. The core window and the application view will continue to live on. You can still create those and work with those as you do today. With the application window type, there are two that we will start with. The companion window, which is basically a window that has some complementary content, not a standalone, in of itself experience. So think of this as, say, a color picker for your Paint app, right? And the second is the flyout, which is a lightweight window that is light dismissible, so that you can do things like the contact card pop out from your application or similar experiences. And like I touched on, there is going to be an independent one, which is a top-level window that works and behaves just like your current main window does today. With each of these, there is an application window experience tied to it. This represents the UX, how Windows UX represents your window and what you can do with it in terms of the title bar, Chrome, light dismiss behavior, etc. But how does this actually make your life easier, right? This is just another window class. We could just rename application view to application window and be done. Not quite. What is happening behind the scene here is that we're introducing a new threading model to UWP. We're adding a single-threaded windowing model. So now that application window runs on the same thread as your application view that you created it from. And you can create multiple of these windows, and they will all run on that same thread. So no more need to dispatch between threads in order to get that color picker to just work. We believe this reduces a lot of complexity for a lot of UX scenarios, because you also don't need to spin up a whole new SAML core. They're using the same. And I want to point out again that you can still create windows that are fully backed by their own threads. So we're not taking anything away, we're not replacing anything, we're adding. So with that kind of the technology out of the way, let's look at a couple of the scenarios that we're enabling. And the first one we'll look at is the companion window. The companion window is things where you want the user to, say, input a new contact into your Rolodex. It's something lightweight. You shouldn't have to spin up a full thread and dispatch between threads to do that. So basically, when the user goes ahead and pops out this window, it positions in a relative place to your application window. The user can go ahead and type, add that content, and this is all on the same thread, right? And when they're done, dismisses it, and if they were to open it again, well, it would open in that same location. So no more Windows is putting it somewhere for you, right? The other thing that is a big part of the companion window is that it's lifetimed with your main window. So if you close the main window, that companion window goes away with it. If you relaunch the app and the user goes ahead and starts typing in a new contact here again, but they have something else they need to do, so they want to minimize this app. Well, of course, minimization also ties these windows together, and they show up only as one entity in the task switcher. And when the user brings it back, both of the windows comes back, and they can continue to work where they were. So let's look at the code for getting that companion window on screen. Well, you've already seen it. It's those 3 lines of code, right? You create the application window of the companion type, you attach your SAML content to it, and you show it. The second type, the flyout, behaves differently, but looks something similar, right? So this would be for your contact, pops up, you have a pin, and if the user were to tap outside of the, if the user were to tap anywhere else, you can move this window around, reposition it. If they tap outside, it dismisses. And even if they tap on, say, the window Chrome, which before you couldn't, as an app, control state of your application when that happened, well, this is us doing the light dismiss for you, so we handle that case as well. Now, if the user were to pin that flyout, it now becomes, in essence, a companion window in how they interact with it. They can tap outside, the window stays around, but you are in control of still moving this window around. You still own it. If they dismiss it or minimize it, it goes away, and they can restore. Right? So it's basically has the same properties as a companion window. The code behind this one, pretty much the same, but you create a flyout. It has this little extra thing where the experience comes in, right? So if you want to change the default behavior for this one, you grab hold of the experience, and you do something with it. In this case, I'm setting the enabled pin state to true, which means that the user can interact with the pin. But the pin is the pin is controlled by the system. You don't have to do a lot of code to make that work. We do it for you. You can, of course, inspect the pin state, but everything is, in terms of how the light dismiss should behave, is taken care of by us. But what about the positioning, right? This wasn't all, right? There's some more magic behind the scenes here. Before we dive into that, let's look at the windowing model itself, a high level. We think of our model as a layered stack, where at the top we have easy-to-use APIs which handle predefined experiences for the user, such as full screen, maximized, picture-in-picture, things that should look and behave similar to the user regardless of what device they're on, and something that we think you could just add a simple line of code to get that working. Under that, we have the environment information describing where in the world you are, what that world is capable of in terms of windowing, and how you should think of the user experience for your application on that specific type of device. We refer to those as the windowing environment. And at the bottom, we have the advanced control APIs. It's basically the APIs that let you do all the stuff that we're seeing here. The positioners for setting size, position, controlling your Chrome, getting hold of all that information and managing it. But around all of this is something also which you're not in control of, which is the user experience that Windows put in place. So we want our users to be safe. We want them to know that if they interact with a window in a certain way, it should behave a certain way. And that's why we have policies that guides how these presenters, windowing environments, and positioners work and expose information to you. So with this, let's look at the positioner. Each windowing environment has its own positioner. So if you're in an overlapped windowing environment, you have an overlapped positioner. It can do a specific thing in that environment. Every type of positioner, so windowing environment and positioner pairing, will work the exact same way, regardless of what device it's on. So an overlap positioner will always be an overlap positioner. It will have the same methods, regardless if you got it on a laptop or a PC or some other device which has an overlapped system. They have different capabilities depending on their type. If you're in a 2D immersive system, well, you can't really set size and position of that window because you're going to be maximized or possibly split. But in an overlapped, you can. And in a holographic world, well, there's a 3D depth to it, right? So that's something different than a 2D screen. And touching on that, these can also be used to move between those experiences. So if you have a system that has a Windows mixed reality headset connected and a desktop, you now have two window environments, and you can target each one of them and even move your windows between them. So let's go back to that code again. And now it becomes a little bit more code, right? But it's still pretty straightforward. So in order to position that window as well, we have to get hold of our windowing environment, which is a get for current view pattern for this one. You then get hold of the default positioner, which is the overlap positioner in our case, because we're in an overlapped windowing environment. Once we have the positioner, we set the size and the relative position, and we apply the configuration. And the reason we have an apply configuration is that we want this to be atomic, so that even if you are changing properties on an already visible window, we want that to be atomic. So you don't see a position and then size, or position, size, and then full screen happening. We want it all to be in a single atomic operation to the user. And I skipped over one thing here, which is the view relative position preferences. These are the preferences that you can give to the positioner for how you want to that window to behave if it cannot be fully satisfied with what you're asking for. Say that the window is so close to the right edge of the screen that if you pop something out to the right, well, it's going to be outside of where the user can see it. Now, we give you the option to tell Windows how should it behave in this case. Should it keep that position but resize the window? Should it keep the size but put it somewhere else that it's close by where you wanted it? And when you position, should you include the title bar as well, or should you just use the bounds of your drawing rectangle? Because you might want to do a pop-out, which pops out content from your app, and you want it to seamlessly just all of a sudden there appears a title bar above it, right? It doesn't move for the user. And we can do this with this type of options to the positioner. And now I can see kind of Okay, so this is how you get one of these in a certain position at a certain size with a certain behavior on the overlap desktop environment, but what if I'm on a tablet and then I'm in a 3D and I just want that picture-in-picture experience to be good. I want something that just works for the user. That's where our presenters comes in, right? This is the other side of the coin, which is the easy-to-use ones. These are our high-level easy-to-use APIs. So if there is a scenario that we think is common to all these devices and we think the user should have access to easily, we provide these presenters to you. So that for the picture-in-picture example, right? If the user uses a mobile phone, they can still they get a pop-up window that is somewhere around their thumb. They can interact with it in a certain way. They know what this is. This is a picture-in-picture window. As they move to other devices, that experience looks slightly different, but to the user, it's identifiable as a picture-in-picture experience. Even if they move into a HoloLens, and that window hovers in their gaze, well, it's still a picture-in-picture experience. The user knows how to interact with this and what to expect. Even if in the future that turns into a 3D avatar, it's still a picture-in-picture experience, right? And what we do is that we give you 2 or 3 lines of code here. You check if the presenter of the type you wanted is available, and if it is, you apply it to your view. And we take care of all the heavy lifting for creating these experiences across all those devices. So now we know a little bit about how to create new views, making them show up in cool ways around a single display. We can do easy-to-use, predefined experiences for the user. But this is one display, right? We know that in productivity scenarios, there are multiple of these. So let's look a little bit at what that scenario would look like. Say the user has 2 of these, his display. You have an app that can play back video, like the Buildcast app we have. The user navigates to that video they wanted to play, but the right-hand screen is is a better experience to play that video on as a pop-out. Now, we modify our pop-outs to say, hey, position me over on that screen. And if you do nothing more, this is what's going to happen. You get a windowed window on the, yeah, I know, there's no better word for that, right? On the second screen, Windows position it for you, and the video plays. That was probably not what you had in mind. You wanted it to go there, and you wanted it to be full screen at the same time. So before we look at the code here, let's go back to that overview of the windowing model again and look at the windowing environment. Like I said, the windowing environment describes what type of windowing is available to you in this current user experience. In a 2D desktop style, which is our overlapped windowing environment, we have information that tells you that, yeah, you can reposition, you can set sizes, but we also have a display topology available to you. This is how you can reason about all the displays that are currently in the system. We call those display regions. And in most cases, it's likely that if you have a single display, you have a single display region, one-to-one mapping. We could potentially do 2-to-1, so you have multiple display regions on a single display. But in most cases, this is what it looks like. If the user then connects a second display, well, a second display region shows up in the system. And depending on how the user have configured them, they are offset differently inside that coordinate system that you have for the topology. So if a third monitor comes in, yeah, a third display region shows up in that same topology. So let's look at that code again. It's basically the same start. We get a windowing environment, we get a positioner, and then we go and find our current display region for our view that we wanted to pop something out of, so we know where we are in the world. And then from the windowing environment, you can get the list of display regions that are available in this current windowing environment. So you stick within the overlapped world that you're in. And once you have that, well, I'm just going to take a shortcut here. I know there's two, so I'm just going to pick which one is not my current one. And then I go to the positioner, and I apply the display region. I set the display region for my view to this other display region. I apply the configuration, I show the window. Now it shows up on that second screen. If I wanted it to go into full screen on that one, well, I add the code for checking if the full screen presenter is available, apply it to the window, and then I show it. So that's how you get between different display regions in the same windowing environment. Now, what if that user has that cool new Windows Mixed Reality connected, right? Let's go back to this view of the world again. Now, when the user attaches a HMD, or a head-mounted display, it will show up as a new display region. Oh, sorry, windowing environment. It shows up as a new windowing environment. And this is how you figure out that the user has more than one type of device in its system. We currently call this the holographic window environment. And as you see here, it doesn't have any display regions or display topology. It's because it's an open world. So in our first step, we provide you a way to get into that environment, but not how to exactly position you in it. So the user will get prompted with the window and position it in the world where they think it makes sense. Now let's look at that window environment, though, because this is how we anticipate for the future in order how to grow this and make it reasonable for you to add support for new devices. So we had our 2D desktop style, which is the overlapped one. We have our 2D tablet style, which is our immersive one. And we have our 3D one, which is the holographic. And that thing that someone is working on in a basement somewhere or a garage or a secret lab, this is where that one would show up as a new thing, right? We define a new windowing environment with all the characteristics for that, and we give it to you as a new thing that you can go and work with. So let's look at that multi-view positioning across environments. And this is where my awesome MS Paint skills comes in handy, because I don't have all those fancy demo equipment that they do for the keynote, right? So here's the user interacting with a 3D world, and at the desktop, there is an expert sitting around that can help them navigate and make sense of what they're seeing. And in that 3D world app, I have a assist functionality, so that when the user finds something that they wonder, oh, what am I supposed to do with this one? They can ask for assistance, and my app pops a window onto the expert side, with guidance for how to help the user make sense of this. The code behind this one is pretty straightforward as well. We have a way of finding out all the window environments that are available to you in the system, whether it's overlapped, holographic, or immersive. So you can go find them from the windowing environment. Once you have that list, you can specify what type you're interested in, or you can get all of them if you just want to figure out what the capabilities are of the total system, right? In our case, we want an overlapped one because we know that the expert is sitting at the desktop. So we get an overlapped, we get the positioner for that overlapped environment, and we position our view into that. Now, since it's an overlapped environment, we could potentially do all this magic for setting sizes or modes, etc. as well. I wanted to keep it readable, So therefore, I'm just positioning into this one. And as you see, I'm working with the view ID here and the application view switcher, which is the current windowing model, right? And I just wanted you to just see that you can work with any type of windows with these positioners, regardless if it's application view or the new application window. So we're not saying you have to move to the lightweight world in order to take advantage of all this. You can continue working with what you're working with today. So that's where we are right now and what we're shipping to you in the next release of Windows, which is the SDK that is coming this summer. But I want to try and do something here that shows you where we're going with all of this and why you should care, right? So this is basically the table stakes we put down for the new system. And I'm just hoping everything works out. This is a pre-release build. We saw our little Rolodex here, where we had our companion view, right? And since we know that now we can create dependencies between windows, wouldn't it be awesome if they were not only lifetime dependencies? What if I could specify that they should move together, right? Without you having to go through all that move size loop that Win32 have to do. You just specify move, and we move them for you. And when we have that kind of dependency, can't we do that for sizing as well? So that it moves out of the way as the user resizes the window, so that they don't get disturbed by a pop-up window that is now hovering over that place that they were editing. And how about that light dismiss window, the contact card? What if I could do transparency here so that it didn't have to be rectangular, right? We can create things that are communicating more powerfully to the user that this is not just another window. It's something that is complementary, that can pop out of your application in more detail and better show to the user that, hey, something is happening here. I have a birthday going. And create all of these experiences for you. So this is kind of where we're looking at taking this and why we're doing all of this work now and starting to roll out this new model for you. And it worked. Awesome. So go back to my awesome paint skills. Since we have these dependencies as well, we can do modality. But not only for the entire app, as is the case today. If you have multiple working documents, for instance, and one of those documents pop a blocking dialog that, hey, the user, you're trying to do something that is disruptive and I can't recover from that. You just want that to block input on those relative windows, right? And the user should be able to continue to work with the others. This is also something that this dependency type of grouping can do for us and for you to be able to create these experiences. And I've talked about the windowing experience that is tied to the application window, right? And if we have that, we can start giving you more powerful versions of that to create new experiences. Say you have something in your app that you can drag out into its own window. And once it's its own window, you want the user to be able to, put it in a place where they can come back to it, snap it to the window screen, and make it dismiss. And when the user comes back to it, you can pop back out, and as soon as it's not near any of the screens, it behaves like a normal window. We call these dockable tools. And this is something we can also light up without you having to do all the heavy lifting for figuring out where is that border, where am I near, is this hovering? This is what we're doing with these kind of objects. So that's still the 2D world, right? Now back to my awesome paint skills, but this time slightly different paint, 3D. We want to be able to allow you to create great experiences in 3D as well. So if you have multiple windows, the user doesn't have to position them all around for that control center that you had in your amazing experience. We want to give you a model where you can position yourself relative to where you are in the world without having to do all the transforms and calculations for how to angle that window and rotate it so that it makes sense to the user. And as part of that, also be able to dock that window or those windows to different things, such as the user, so that when he moves around inside the world, the window sticks around, so that they can interact with the world and see information in their window, for instance. But the user have more than a face. Sometimes we have the 6 DOF controllers. Why not be able to position your windows there as well, so that the user can look at it at different angles or use it as a paint stroke in 3D. And once you can do that, we can also reason about other things in the world, not only the user, but the objects in it. So if you have your windows, allowing the user to, say, put them on a surface, on a table, or on the wall. And this is, of course, something, if we can do it for the user, we can do it for you. So that you can say, hey, I want my whiteboard app to show up on a wall. Just position it on a wall near me. Instead of having to go and reason about the world, figuring out all the areas that kind of sort of look like it's flat, and then position your view there. So this is a little bit of where we're going with all this and why we think that you should care and join us on this journey. And now I know everyone in here is thinking, so when can I? Right? And like I said, the table stakes are being put down now. This is the next release of Windows this year. We're giving you all the basic building blocks, the windowing environment and the display regions, the first types of lightweight windows, some of the presenters, such as full screen, maximized, picture-in-picture, and 2 of the lightweight window types. Going forward, this is kind of where we light up all this goodness that I've been talking about, right? And it's an evolving roadmap. This is not locked in stone. We want your feedback. I want to hear all your awesome scenarios so that I can prioritize and make sure that we do the right thing. And we unlock those for you as soon as possible. Because that's my passion. I love Windows in Windows. And I want you to be able to do awesome things with it. So to wrap this up, first SDK this summer. You saw the table stakes we're putting down. We're continuing to grow this. We're continuing to polish the experiences. We're continuing to not only introduce new objects, but to grow those objects with more powerful capabilities over these releases. And please, feedback, 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 feedback. If you find me on Twitter, my own Twitter handle as well is not on this slide, but it's on my badge and it's in the talk. Reach out any way you feel is a good way to give me that information and your scenarios, whether it's the formal ways of user voice or our formal Twitter or my personal one. I love to hear from you. So with that, I want to thank you all for coming. And I still have a couple of minutes, so I can take some questions if you have them. Otherwise, thank you for coming.
So, is this working? I don't know if you guys can hear me or
Can we
not.
get the question mic on?
Okay, is that better? There we
Yeah.
go. Okay, so I'd really a question more for like the immersive experiences people. So a lot of us use middleware like Unity or Unreal or others to have to create a lot of our experiences, but XAML isn't always available to us. Now, I think you spoke on that kind of briefly at the beginning where you had detached the UI thread, which probably will help us a lot with that, to be able to get these XAML components to render over our other apps. And a lot of these are like DirectX or I don't know if you guys are familiar with the D3D version inside of Unity, but that kind of is a little bit harder for us to implement. Do you see this being something that will help us do that a little bit better?
So the question is if or how we can enable you to use SAML content in other frameworks such as the Unity framework in 3D, where this lightweight window doesn't really help you. Yes, we're looking into that. It's not something we're ready to ship yet, but we're looking at how you can take, for these window objects, you saw the connect content that I had, which took a SAML object. We're looking at how to integrate this with different frameworks and enable you to be able to connect different types of contents inside the world, whether it's 3D, Unity, XAML, D2D, whatever, right? Direct composition, so that you can create the experience that is right for your app. But we're not quite there yet, but that's where we're shooting for. Yeah.
And you didn't explicitly talk about this, but is it possible to specify which windows should be displayed on which displays? Like
yes.
If I have like 3 screens, and not only the primary window, but also the companion window. Like, can I have it that the companion window will go to always display 3?
Yes, so the question is, can I position any view of any type on any display or display region? And can I control that? And yes, you can. So with these APIs, they're basically taking an ID. And even in the new world, the new application window, it has an ID tied to it. So you can take this ID and say, for this ID, I want it to show up on display 2. Whenever the user opens my app, I always want that to show up on display 2. You can control this within your application, yes.
Okay, so Windows is going to have a default, and I can override that.
Yeah, so the default Windows will try to do the right thing depending on where the user is. If you don't, there is no default positioner, so you will always have to query what type of environment you're in to get the type of positioner you want to have, which means that if you want to create the same experience on both an overlapped and an immersive system, if that immersive system supports multiple displays, you would have to do special coding for making sure that that works.
Thanks. And just, I think I was delighted to see that you talked about the shaped windows. So I'd be able to like control the shape, transparency, whether I want touch on it or not.
This is yes, that's our aspirational journey. We're getting there. That's, like I said, this was like super pre-release versions of it. But yes, you will be able to control the shape, the position, and kind of do possibly even some animations around how that shows up.
Cool, thanks.
Hi, I have 2 questions. The first one is about reasoning about multiple displays. You showed the APIs that allows us to inspect that state. Does it allow access to raw pixel information, like how large the displays are in pixels rather than device-independent pixels?
So the question is if you, from this display region, can go down into more detailed information about the panel that is backing your display. And the answer is yes. In most cases, so if the display region isn't virtual, so if it's actually backed by hardware, such as on this kind of displays, you can get the monitor device for that display region, and you can find all the raw information about the device itself.
Is the monitor device a new API as well?
The monitor device, or is it monitor? Display monitor, thank you, Nior. Display monitor is an object that is also coming in the next release of Windows.
Okay, and my second question is about showing the windows. The API is try show window async. Does that mean that the API isn't reliable? When would it fail? And what do I do if it fails?
So yeah, so the question is, there was a try for the show. Can it fail? Why would it fail? Is it not stable? Like I said, there are some Windows UX policies in place, right? That can change depending on what the user is currently doing with the system, such that if, for instance, they're in a focus mode and you're trying to pop a window into that display region, Windows will be able to say, no, you can't go into that display region. And we will get you the information why it failed for you, right? So why the try didn't work. In most cases, it will work. There is like rare policy changes that makes it say no. But when it does, we will give you the information of why so that you can turn around and do something clever about it, or just say, okay, I won't do that right now.
How's that information exposed?
So with the async object, on the async object, you have the return codes for what happened to the failed
Okay,
to the failed try. Yep.
thanks.
Cool. Again, thank you all. I'm going to be around, so if you have any questions you want to pop out, just I'll be down at the expo level and the windowing and composition booth. Thank you again so much for coming.